Hey guys, welcome back to the channel. Today we're going to do a project where we're going to take two of these Super Beast systems, or 24 volt. We're going to take the positive, series it over to the negative, and then they'll give us 48 volts all the way across. And then we'll use a 16S BMS in order to get our 48 volts output. Now, full disclosure, these were given to me by batteryhookup.com for this demonstration. We will be using these lead wires in these bundles for our BMS leads, and we won't have to cut the wires. I have connectors and we'll show those in a second, but you can. But word of warning, if you just go into this bundle with wire cutters, you may create a short and burn some stuff out. Well, just be very, very careful. Cut one wire at a time, and I would insulate that wire before moving on to the next one. There are only 8 hot pins in here, or 9. But still, be very careful if you're going to do it that way. That's why I kind of suggest using these pins, these connectors. So let me show you those now. Here's a 23-pin connector. I found this on the internet. This is not perfect. It needs a little bit of modification in order to fit, but it's super simple, and I'll show you that when it's time. I also have these 3D printed enclosures that we're going to put in, and I also have some terminal blocks that will give us our inputs and outputs for battery. We're going to have 4 connectors on this side that will allow us to hook up a charger, other batteries to add capacity, and other things that we'll get to. Our BMS is a Dali style. I don't think it's a Dali brand, but it's very close. It's a LiFePO 4, 16S, 48 volt, 100 amps. Now these cells can do well over 100 amps. Just one can do over 100 amps. And we have 6 in there in parallel. But I was looking at the math. At 48 volts at 100 amp, that's 4,800 watts of available power. We're going to be powering a 3,500 watt inverter. That's plenty. Being low on the low end of things, we won't have to worry about heat. So even if we run this at 100 amps, the BMS might get warm, but the battery shouldn't even get close. So I think 100 amps is a really good size. We have our lead wire plug that we will connect to those terminal blocks. The pin connectors. We also have a Bluetooth adapter for the BMS, so we'll be able to monitor things with our phones. So the next step, what we're going to do is we'll kind of bind these together. These systems have these little grommets that are connected to the shelling. I'm not exactly sure what they use these for, these batteries were used for, but I'm going to take advantage of them, and I'm going to create a piece of wood that goes over these entire 4 and kind of bring these together, and then I'm going to put a board on it this way to mount all of our electronics. And so let me go work on that now, and so when we get back, we should have that all mounted and ready to move forward. All right, we've got our board attached. As I said earlier, these grommets, the case, are not super rigid. There's some flex there, so don't consider this as support if you're going to try to move this whole thing, which is now quite heavy. I think probably around 90 to 100 pounds. I have a ratchet strap around both to kind of help, and I may put another one. But again, this can kind of be taken apart. You have to take this board off and then get to the screws that connect it to these supports. But I'm planning to try to get a friend to help me move it to its permanent location once it's done. All right, for the next thing, I'm going to go ahead and wire up our pin connectors. I want to talk about this first. I've had a person in my comment section ask for a detailed understanding of how a BMS is wired up. And so we're going to go over this. So I want to think about this as, here is the ground spot up here. And then there's a positive spot here. There's a ground spot here. And then there's a positive spot here. What we're going to do is bridge these two, and that will create a flow from ground all the way to positive. All right, so each one of the segments in these batteries has a lead wire that it comes from these pins. All right, now they have this diagram on batteryhookup.com of where each position is. So this I consider as bank 1, and then this is bank 2. So we're going to start at this, which is ground. I might do an illustration, and I may put it on the screen now. But pin 0 is like ground. It's the first connector lead wire. And then it goes to 1, which is up here in the top right corner. If you want to learn about the orientation, the spring connector, or the release connector, is upwards. And so the ground is 0, second row, first one on the left. And then position 1, which would be cell 1, is top right. Then it goes to top left for 2. And then 3, 4, 5, 6, 7, and 8 as it goes across. All right. Now, when we bridge these two top together, we are also connecting those lead wires that go to each position. So now it's all one wire instead of a bunch of separate ones. And so what that will do is it will make on the second bank that 0 position is the same as the 8th position on this one. Because we're connecting them up here, they're all one wire. So we don't need to run it twice. Matter of fact, we need to pick which one are we going to do. Are we going to use this one to go to our BMS, or are we going to use this one? You can use either. It doesn't matter. They're all connected the same. So the next position after 8 would be top right of the second bank is 9, and then it goes all the way to the top left is 10, 11, 12, 13, 14, 15, 16. And I will have a picture of this. I'll probably take a picture just like this, and I'll lay out each port to the number in the bank. All right. So my next step is to go ahead and wire those up. So I'm going to just do a time lapse of that soldering session. We're going to be putting them in our 3D printed cases. I also have a little cap that the wires will go through, so it's nice and neat. And so let's work on that now. All right, before I get started with the soldering, I just want to go over the connector. Here's the pin connector. If you notice in there, there's 2 protrusions where these are keyed. So they're designed for a particular application or a particular plug. The pins line up perfectly and it sockets perfectly, but those 2 extrusions are actually going to prevent it from seating correctly. So all you have to do is go in there with some needle, some plier, wire cutters or something sharp, even an X-Acto knife, and knock those down. Here I can show you one that I've already done. So if you notice in there, they have been removed. I know it's hard to see, but they have been removed. And also what I've also done on the back is I removed all the pins I don't need. Like I said, that middle row is where the ground starts, and then that row there is where all the positions of the leads go out. And you'll see me as I solder them again, and we'll go over it one more time when it's all complete. So I'm going to work on that now. No, it's not pretty, but they're there. If you could notice, I bent some pins up and then down to make some separation. Because remember, these leads are not protected, so if there's a short in there, they're just going to melt the wire. Should be not ridiculously terrible, but the BMS will cut off, and it's not good. So after I double check my wiring to the right positions, I'm going to put hot glue all over those connectors and make sure that nothing could create a short and that the pins can't move to create a short. Then we're going to seal them up in their housing and mount them on the board. So I'm going to work on that, and we'll catch you then. All right, before I kind of hot glue all of these connectors and seal them up in their boxes, I wanted to do a quick test. So I kind of got it hacked together. So we have our 2 connectors connected. The pins are running to the BMS. I've got power leads running to the BMS wires on the ground side, positive side, and just making sure that all the cells showed up. BMS has showed up on Bluetooth. all the cells. I got one that's a little bit concerning. I'm hoping that when I do a charge and let this balance out, it should be good. So that's the test. Now that that's good, I'm going to go ahead and hot glue these connectors, make sure they're safe, put them in their boxes, and go ahead and mount them on the box so we can move on to the terminal blocks and then the power connectors. Let's work on that now. Alright, we've got a bit completed. We have our pin connectors mounted, our 3D printed enclosures, and mounted pretty good with our BMS wires wired up. Then we have over here our bus bars. This will be the ground side, this will be the positive side. We have these are called Anderson connectors. They usually can handle like 50 amps. I don't think I'll be running them that hard. Next steps is to figure out where to mount the BMS to get it to the bus bar and to get to the posts from the batteries. So I'm going to work on that next, and we'll tune in, and we're getting really close to powering something. So stay tuned. Alright, we're getting that much closer. Let's go over what we just finished up. Found a mounting spot for the BMS. And tried to clean up these lead wires the best I could. Added a bus bar down here for the ground position. So this blue wire, which is the B minus, needs the battery feed. So we'll be taking wires from up here and going into here. And the reason I needed a bus bar is I wanted a clean connection. I didn't want to have to cut this wire and try to patch it. So I'm going to run 2 wires of the same gauge as these to the ground up here. Here's the Bluetooth adapter. I think I'm going to try to find maybe 3D print a little fixture to hold it right here and try to clean up that wire. Or I may just pull it off. I don't always need the BMS, the Bluetooth, so I can always just put it on when I need to do some readings. I'm going to make the patch wire from the positive to the ground, the second battery, and then the wires from here, the positive, all the way to this bus bar. So just to cover for that person who in my comment section who was wanting to know more about BMSs, the BMS only deals with the ground side. So this is like a big switch on the ground side. B minus goes to the battery, P minus goes to whatever you're powering. If that's an inverter, if that is a power supply, if that is a light bulb even, whatever it is, P minus goes to that. And then the positive is just straight off the battery. So you could just feed it off the post up here, or you can go down, or once we connect the bus bar, you can use these connectors or just tap off one of these things. I did some measurements on my inverter. I'm not sure I'm going to be able to get it to fit over here. So that may just be a peripheral that you just plug in. Let me finish wiring that up, and then we'll do one more review from a top view of the batteries and then all of the board here. So let's do that now. Alright guys, we're practically done here. We've got our lead wires off the ground there. We have patch wires over from the positive to the ground of the second bank. And then we have our wires going from the positive to the board. That right there is the simplest way to get a 48 volt system. You just series them together. But we went a step further and we added BMSs to it. So let's just go real quickly. At the top there, the black boxes, we have the 23 pin connectors we're using to get to the BMS lead wires. We have the BMS right there underneath that. Underneath that, we have a little bus bar that takes the ground and takes those 2 wires and brings it into the B minus of the BMS, which is that blue wire. And the black wire is P minus, which goes to whatever we want to power our load. And then we take that to the bus bars and then over to the connectors, and then we have an inverter hooked up right now. So let's do a quick little test to make sure everything's going, and I'll show you a video on the BMS app and just show you what it's drawing. Alright guys, as you can see here, we've got a load going onto the inverter. This is a little heater. Right now it's at low setting, so it's about 750 to a kilowatt. And on the screen here you can see it's drawing basically anywhere from, I've seen 14 up to 26 amps. Heating elements just go up and down, so there's not a steady load. But our batteries are handling them fine. We can see that all the cells are reporting in. At the top there you can see the maximum voltage, the minimum voltage, and the average, and the difference. So right now we're only 0.056 volt difference between the cells. That's not too bad. And according to this load with 48 amp hours, I'm guessing 25 to 20, this should last 2 or 3 hours of use. Obviously a lot less if you have some smaller load. Well, that's going to do it for this video. Hope you guys enjoyed. And if you want to get this battery or anything else from batteryhookup.com, please use my coupon code TECH, T-E-C-H. That helps out the channel a lot. Thank you guys.